Should maths and science be taught in a cross-curricular way? Over the years, there have been many different interpretations of the term cross-curricular teaching and learning. It has been known to be called project work, topic work, project-based learning, integrated learning, interdisciplinary learning, or thematic work. Barnes much better defines cross-curricular as when the skills, attitudes, and knowledge of different disciplines are applied to the understanding of a singular theme, experience, or idea. For example, when subjects are interlinked, such as science and maths, it can allow for simultaneous progression as maths skills are applied in science contexts. Barnes further discussed how the entire world that we live in is naturally cross-curricular. Therefore, he provides clear rationale as to why we should teach children in this way. However, the cross-curricular approach in the primary curriculum has been widely debated for some considerable time in regards to its progressive child-centred approaches. These help children to make sense of the world in which they live, whereas traditional approaches place focus on essential knowledge that children need to learn through independent and discrete subjects. To understand more about how we have moved on from discrete teaching approaches to cross-curricular, it is important to begin with its history. In 1923 to 31, the Hadder Report endorsed that teaching a project or topic is preferred to the division of separate subjects. The Plowden Report in 1967 took particular interest in cross-curricular teaching, stating that knowledge cannot be separated into different compartments. In argument, the Three Wise Men in 1992 stated that there should be more emphasis of teaching discrete subjects due to criticisms of poorly planned topic or thematic work, which resulted in superficial learning. As a result, the 1999 national curriculum brought about a change with individual programmes of study for each subject. However, despite this, Boyle and Bragg carried out a 10-year study which revealed subjects were still being taught in a cross-curricular way. This led Ofsted to recognise that cross-curricular teaching was a feature of successful education within primary schools. In hindsight, the 2009 Rose Report accentuated the need and importance of cross-curricular studies, stating schools should teach subjects in a combined way to enable a much richer curriculum for all. More recently, the national curriculum in 2014 enables teachers to have more freedom in how they teach subjects. Could this reinforce the shift towards more cross-curricular teachings within schools, and is this best? So why should we teach in a cross-curricular way? Teaching in a cross-curricular way can enable children to make the fullest sense of their world, since children do not assign particular activities to particular subjects, and this approach more closely reflects the main way in which children learn. Additionally, Ofsted state that by teaching in this way, children are able to apply the knowledge and skills that they have learned in one subject into another, thus reinforcing their learning and increasing their understanding and confidence. This caters for strong progression. Furthermore, it provides a context so children can learn more effectively, as they are able to see how they can use and apply the knowledge and skills they have learned to different contexts or situations. This provides the answers to when will I ever need this, and helps children to remember skills and knowledge through content. In turn, children can make independent connections between subjects and develop problem-solving skills. With this in hindsight, it suggests that if children are not given the chance to make secure connections between subjects through such approaches, they are only gaining partial insights into problems. This can be a concerning issue, since in order for children to understand problems, they need to be provided with opportunities to develop and transfer their knowledge from one subject into others, reinforcing the idea of teaching in a cross-curricular way. Marzano in 1991 elaborated on the importance of this, stating that integration across subject areas and broader life experiences provides an education which is more relevant and meaningful for children. It is seen as a way to support the transfer of learning and skills from one situation to another through synthesizing information, teaching pupils to think and reason. With this, children can problem solve using existing knowledge whilst gaining new skills in the process. This provides a more relevant curriculum which engages children's interest. Although there has been a broad welcome for Rose's cross-curricular teaching approach, in contrast, such pedagogy also comes with criticisms. It has been said that some subjects lose rigour when taught in this way due to a lack of depth. This can be due to teachers choosing to place more emphasis and learning on a particular subject that they feel most confident in. This can leave others to be skimmed across and taught insecurely. Another reason for this is due to the inability to study subjects in depth because of the high integration between different subjects. This can result in subjects losing their own identity and children being unable to pinpoint specific areas of learning within subjects. Consequently, this can lead cross-curricular teaching to be counterproductive and children left with not enough essential subject knowledge that is needed fundamentally. Cross-curricular links between some subjects are more natural than others. In a research study by Greenwood, it was revealed that worry and fear by teachers is that subjects may be forced together. As an effect, teachers make links with subjects that aren't naturally there, making them more contrived. These tenuous links hinder children's learning and do not enhance it. Therefore, it has an opposite effect of what is expected, with parts of the curriculum being either missed or repeated, reinforcing the idea that some subjects need to be taught independently and require integrity to be covered. Assessment is another challenge, since traditional forms of assessment become limited as they focus on subject-specific knowledge, failing to consider the ways in which children can apply these in a cross-curricular approach. This requires teachers to be flexible and to develop new strategies in how they assess, which can be time-consuming, another organisational type issue. But what are the issues of teaching maths and science specifically in a cross-curricular way? A dispute in teaching these two subjects together is that the children's science skills and conceptual development needs must be matched with their mathematical development needs in order for them to be able to carry out the scientific inquiry successfully. This can be a presenting challenge for both new and experienced teachers. It requires careful planning to children's individual development needs against the combined subjects. Therefore, it is important that schools provide training for the planning and delivery of cross-curricular lessons. This can help to reduce teacher difficulties, worries, and aid in preventing pupils from missing the benefits that come with cross-curricular work. In coincidence, where there is effective collaborative planning in the two subjects, there is a direct result of higher pass marks and test results, according to Pike and Lynch. This emphasises the importance of careful consideration and planning for cross-curricular work. The Wellcome Trust report in 2005 revealed that a high proportion of teachers felt they lacked the confidence, expertise and training to teach the science curricula effectively. This poses great dangers to children's learning as it can allow for science to be watered down when taught alongside mathematics. This reinforces the matter of subject knowledge of teachers needing to be strong regardless of the teaching approach. This also poses the question as to how beneficial is teaching maths and science in a cross-curricular way to children's learning. According to Shield, maths is the language of science. Just as well, science provides an ideal opportunity for children to apply and understand mathematical ideas. This puts mathematical skills and ideas into relevant scientific context, which shows that the two events do not happen in isolation. Therefore, it would make sense that the two subjects are integrated. Science provides mathematics with interesting problems to investigate, and mathematics provides science with powerful tools to use in analysing them. In coincidence, early on, numbers enable young children to talk about science and explain their findings. Therefore, the beginnings of early counting are intrinsic to their understanding of the world in which they engage with as scientists. This makes it obvious that counting and mathematics are key to unlocking scientific inquiry. Furthermore, HMI stressed that learning depends on one's ability to recognise relationships between concepts. Without this, teachers have found that children struggle to make sense of their mathematics and when applying specific skills which have been extensively taught. Cross-curricular contexts can enable pupils to make links between subjects, allowing identification for when they will actually need specific knowledge for. This provides them with more transferable skills to use in real-life problems with increasing confidence. In support of this is constructivist theorist Piaget, who discussed that children must be active participants in their learning in order to first assimilate knowledge and then to accommodate and adapt this knowledge to real-life contexts. Children will take the math skills learnt in science contexts through doing and be able to apply them with a firmer grasp, finding it also easily applicable to a more varied set of problems. However, if mathematics and science are segregated, the context of the investigated phenomenon will be lost and children are less able to solve real-life problems. Further to this, Boss et al. State how the maths and science principles are highly similar. Supportively, Fox and Surtees in 2010 state the mathematical skills which are used in almost every scientific experiment and investigation for successful learning application. These are classifying, counting, measuring, calculating, estimating and recording. For this to work well, it is important that children learn the skills and facts in maths first, so they can then transfer the abstract skills learnt over to different contexts and purposes like science. Fox and Surtees provide examples of these: the natural world, growth in green plants, life cycles, healthy eating projects, and practical work on circulation and breathing. CT is a very important tool in teaching and learning of today. It is not just an added extra, but a necessity in this ever-developing technological world, which is also identified by Ofsted and with interlinking subjects of the national curriculum. Although we should not replace subject teaching, it is a very important tool which can be used to enhance learning in subjects. Where it concerns maths and science specifically, data loggers are one type of ICT which can be used. They collect data for long periods of time, manipulate variables and observe cause and effect, access data and graphs quickly, bypassing the tedious and time-consuming task of producing graphs by hand. This limited time spent on the lower-level skills of recording, gathering and presenting of data allows more worthwhile time for higher-level skills of interpreting and drawing conclusions. This can also be quite beneficial to children with poor motor skills, allowing for progression in subjects such as science without allowing others to hinder it. Another key ICT tool used within the classroom is the interactive whiteboard. Harlan and Quarter state the positive of its use as it enables for collaborative working, it's multimedia and more engaging for children. However, the setbacks are that there can be issues with seeing the board, so there is unfair distribution, and teachers may be over-reliant on this when teaching, and ICT should not be used to replace subject teaching. So, should maths and science be taught in a cross-curricular way? Yes, there is clear evidence that cross-curricular teachings very much outweigh long discrete teachings, more so where it concerns maths and science, as they are perhaps a special case, which mean the two are such natural partners they cannot be taught in isolation from each other. Cross-curricular allows children to be active participants in their learning, as they can apply and use mathematical skills and knowledge to real-life contexts. This is a more engaging and relevant approach to children's futures, and caters for strong progression in both subjects simultaneously. However, even the implications for this approach can be overcome through training and experience to be at its most effective. Teachers must be confident in their subject knowledge and be sure there are clear links between subjects. Children also need to be taught essential skills first through discrete subjects so they can then begin to successfully transfer those skills over to different subjects in cross-curricular teachings.